Today we're looking at investigating and applying the sine law in acute triangles. So you can see I've drawn in a triangle ABC, and just like in when we were talking about the Pythagorean theorem and doing the primary trig ratios, what I've done is I've just drawn in the sides opposite to all these different angles, and notice I've used the lowercase letters in order to do that. So, here's angle A, the length of this side is little a, here's angle B, the length of this side is little b, and here's angle C, and therefore this whole side is labeled little c. I just want to talk about the definition of an acute triangle. It's where all three angles are less than 90 degrees. So all three of these angles are less than 90 degrees, and as you know, in a triangle, all three angles have to add up to 180. The sine law states that any acute triangle, the ratios of each side to the sine of its opposite angle are equal. So essentially what this means is you can have this situation. The length of side A over the sine of angle of its opposite angle is equal to the length of side B and the sine of angle B, which is also equal to the length of side C and the sine of C. You can also, if we were to take the reciprocal of this of the sine law, you can reverse everything or take the reciprocal of everything, and it would just simply be the sine of angle A divided by side A equals the sine of angle B divided by the side length of B, which is also equal to sine of angle C divided by the length of side C. So when you think back to, even you think back to grade 9 math, these are ratios, right? And when this ratio is equal to this ratio and they're equivalent, you have you have proportions going on, or these are all proportionate to one another and they all equal each other. That's essentially what the sine law is. And later on in the lesson, I'll just show you how the sine law is derived. So there are two instances in which you can use sine law. The first case, you must have two sides, and one of the angles must be opposite to one of the two sides that are given. The second case where you can use sine law is when you have any two angles and any side. Now I want to talk about how the sine law is derived. So I've drawn in this triangle ABC, and all I've done is drawn in a perpendicular bisector to note H. Again, I've labeled each side opposite to the angle little a, little b, and little c. And, it being sine law, obviously I have to use the sine ratios. So sine of A, here's the opposite over hypotenuse, it's H over B. The sine of B is H over A. And like before, or, it's a recurring theme, now I have two equations and two unknowns. H and A are unknown. So now I can have this situation where I can isolate one of the two equations. So let's isolate equation 1, let's say. So this one would become, if I multiply both sides by B, the new equation becomes H equals B sine of A. And if I say substitute 1 into 2, so now I have sine B is equal to B sine A divided by side A sine B divided by A. Okay. what I can do at this point now is multiply both sides by 1 over b. And my final answer ends up being, again, we do get part of the sine law, which is sine b over little b is equal to sine a over little a. And if you repeat the process with the other two angles, with b and then c, you get the same thing. Now I want to take a look at an example. So I've drawn in ahead of time a triangle, 55 degrees, 70 degrees. If we want to fill in some of the missing angle measurements, this one here would be 180 minus 55 minus 70, and it too is also 55 degrees. Okay, don't have to do that. This does satisfy one of the conditions in order to use sine law. Remember, one of the conditions was if you had any two angles and any one side. Okay, it's not a, it's one of, or you have two angles with one side that's opposite to one of the angles. Okay, so if I do sine 70 degrees divide by, so this side is opposite to the 70 degrees, 9.2, and this is centimeters, is equal to sine of 55 degrees divide by x. Okay. At this point, if you want to make the math a little bit simpler and you don't like the fact that the x is in the denominator, let's take the reciprocal of everything. So this is 9.2 divided by sine of 70 degrees is equal to x over sine of 55 degrees. All I have to do now is multiply both sides by sine 55 degrees. And now if this and this cancels and I'm left with x all by itself on this side, that means x is going to be approximately 8.0 centimeters. Again, if you were doing this as a test, I would expect some type of concluding statement. I won't write that in just for the sake of not making the video as long as it needs to be. So the first example, we were looking for side length. We wanted to find side length. In this example, we're required to find all the different angles. There's one angle that's very easy to find. This one here is 180. So this one here is 180 minus 124 degrees, and so we get 56 degrees. Okay, so now I have the condition where I have at least one angle, two sides. One of the two sides is opposite to the angle. So let's say sine of r I've mislabeled the diagram. Let me relabel the diagram here. So the sine of r, and this side's opposite, so divided by the side length of little r, which is 112, is equal to the sine of p divided by little p, and let me be consistent and we'll make this little r. So that means the sine of r divided by 112 is equal to the sine of 56 divided by 98. Okay. I did this on purpose because I know I need to find angle r. That means I need to multiply both sides by 112. Remember, when you're finding angles, we now have to use the inverse trig functions. So that means angle r is equal to sine inverse of this whole expression here. So you need to put in brackets sine 56 degrees divided by 98 times 112. Okay. When you do this calculation, the angle R ends up being approximately 71 degrees. So this angle here, 71 degrees. And now finding angle Q just becomes an exercise of subtraction. So angle Q is equal to 180 minus 56 minus 71 and equals 53 degrees. Okay, so that concludes the lesson on sine law. And so for tonight, please make notes, summarize some of the key ideas, and come with some questions.